Hey guys, great to see you again. Thanks for having me. Um, Thanks to David, Zach for putting this together and allowing me to interact with you folks. The topics that I kind of wanted to go over with today. First thing was I try to pick stuff that we get calls quite often about, and trying to assist in end users or dealers or manufacturers. One of the bigger issues that we hear a lot of time is the first thing that somebody will say in an installation that's failed is, hey, we had a glue failure. Well, I've been doing this as the lab guy for 33 years now, and I've only remembered one actual glue failure, that it was actually the glue's fault, meaning that the glue was not made as it was intended to be made. I'm not telling you that it's not possible to happen, but it is certainly not the probability. The probability is that something occurred to the glue during its usage or past its installation, with location issues, water mitigation, some sort of contamination, other problems that have acted on the glue, creating those problems. So we do a lot of testing for manufacturers and for adhesive manufacturers, flooring manufacturers and adhesive manufacturers, and sometimes combined with those to help look at the properties of adhesives and what they will do, what they will withstand. So I was going to discuss a couple of those tests. I've made a video I'll input in here to kind of show you one of the tests that we run and how it's determined. But the main thing I want to talk about in this thing is people ask us to do, oh, can you test the glue? Yes, we can. The standard ASTM procedures for peel, meaning separating the adhesive bond from the substrate, or the shear, meaning you're separating the material in a situation where you're horizontally pulling those things apart as the floor covering would move across. That's shear pressure, or puck, meaning this straight up, not a peel, but complete Z direction movement. Those are the three tests that we use, but the tests are not as important as what occurs before the test. The standard test is you adhere the materials together that are going to be tested, and then you wait 10 days and break them apart. Everybody does good in 10 days. Chewing gum does good in 10 days. The problem is the degradation of that adhesive bond over time and conditions exposed to that. So when you say, oh, the adhesive is now liquefied and it's failing, I can assure you, whatever test I run on whatever material that I put together, it is not going to liquefy in 10 days. So the point to my diatribe here is to say that standard test is only the way that you're supposed to pull those materials or separate those materials to get a baseline of what the performance is going to be. The real answer is, what do we need to do to that assembly to establish what has gone wrong and what the effect of what's going wrong is having on the adhesive. So you see a lot of the information from manufacturers output for, oh, we can withstand X amount of pounds of water vapor, X amount of humidity percentage wise. Those things aren't implemented as part of the standard ASTM test. So when you have a problem, number one, to recreate that, if it took 18 months to create the problem in the installation, I can't do that in 10 days. So it's going to take a while to expose a material to get to where it needs to be for me to answer a question or try to help answer or provide information about that says, hey, we believe it to be X that's failing. We believe the marriage is compromised because of Y is occurring. Again, to try to help you guys sound more intelligent, to try to help you work on actual issues in the real world, it's good to know what I'm telling you, because you can't promise a guy I'll have an answer for you in 10 days, because I can promise you, you give me anybody's glued to anybody's flooring for 10 days, and you're going to get favorable results. Hope that all makes sense. So what do we do? Well, there's where the conundrum is. It lies in what do we need to do? Do we need to run 30 days heat aging? Do we need to run 30 days humidity aging? What humidity do we need to go to? We can provide conditions to the floor covering or to the assembly to address those conditions. Do we need to run it 180 days? Do we need to run it 365 days? What do we, because we can accelerate certain conditions, certain issues, certain occurrences. So, for example, I personally believe that pH is the number one cause of adhesive failure when there's concrete involved. pH being brought up from the concrete through moisture that can penetrate through there and then attack the adhesive bed or the marriage of the adhesive to the floor covering or the adhesive to the flooring or the slab. That, I believe, is to be the number one issue over time and what I've seen. Again, that's my personal opinion. Take it for what it's worth. So if it takes a year and a half for that adhesive to break down, and we test the pH of that floor covering or that slab, and it's 12 and a half, I can only go to 14. That's as high as the scale goes. 7 is neutral. 9 is about normal for what you see on reasonably good slabs, and I use that term lightly. So when you have 12 and a half, I can't make it go a lot faster by putting 13 and a half pH. So if it withstood 12 and a half pH for a year and a half, it's probably, if I even made it at 14 with some sort of blend of chemistries and held that even at a high temperature for a while, it's still going to take 30, 40, 50, maybe 70 days to break that glue down. Number one, most glues are over-engineered. So with that being said, you got to have some sort of a plan. Happy to help develop those once I kind of know the particulars, to try to assume what's going on and try to determine what conditions this material is seeing, and then for us to try to replicate that and determine if in fact that's what's breaking the adhesive bond down. The shear tests are probably, in my opinion, the most important for most materials because that is the bond keeping the material from moving back and forth. Peel tests can certainly be important as well, but a lot of times, depending on the material, if you're using carpet tile, they're using pressure sensitive adhesive, meaning it's sensitive to the pressure used to pull it up with. So if you test the peel strength of a pressure sensitive adhesive, it's not going to be that high because it's made to release. It's the intent and purpose of it. The longer it sits there, year after year after year, it gets actually firmer and firmer if no conditions are affecting it to the negative. So it becomes a little bit more of a permanent bond. But again, depending on what the material is and what its usage is, you may not have any interest at all in a peel test. And the pug test is more, the Z-force test is only used as a relatively small amount of cases that I would suggest it. So I almost always would say use the shear-based test, and peel would be secondary, again, depending on what it is. If you're dealing with ceramic tile or wood, obviously peel doesn't matter because it doesn't peel. It's going to break loose as soon as you break one edge of it. The whole thing breaks loose. So again, that's some general information. Watch the video. We can see how the floating roller peel test is performed. It's a piece of PVC that we've got glued to a board with some adhesive just to bond together. At least you'll see what that test looks like. Thanks. Yep. As you can see, the flexible adherent is being peeled away in the top jaw from the mineral fiber cement board, pulling across the floating roller heads. While this is occurring, the tensile tester's data acquisition collection system is monitoring the forces required to separate those bonds or the adhesion from each other, and it is collecting that data in a graph form. We will take the 5 highest peaks, and that is our answer. The second thing I wanted to cover today, again, just because of the volume of calls that we get asking for resolution for a particular issue, is scratch testing on resilient type flooring, and I'm including SPC, LVP, vinyl, even can look at laminate and even wood to a degree as similar test apparatuses that are used. The first thing I'll say is there's not really any minimum criteria of performance that the industry establishes as a minimum. So, for example, if we test for tough bind in a carpet as a problem, there are established industry minimums that exist. 3 pounds for a cut pile, 6.25 pounds for loop pile, based on FHA standards, and that becomes sort of the industry standard over the last 40 years as an understood, or delamination strength at 2.5 pounds per inch. So those are established minimums that, if you fail those, there's precedent out there that you're going to get a claim, and it's going to be easily substantiated, especially if it goes to court, because that precedent exists. Scratch is a different animal, and there are standard test methods that exist to examine the performance and how materials react to scratching. First of all, scratching is sort of an ambiguous term. It seems real simplistic when you say it, but then you start thinking more deeply about it. There's all kinds of scratches. When I slide into second base, when I used to slide into second base playing ball, you get a little red strawberry. That's an abrasion. You're not actually gouged out with some sort of a hole or crevice or a streak in your skin. It's a strawberry that you've just abraded by all those fine particles of sand or dirt that created that friction and caused you to skin yourself a little. That's different than your sister, grabbing hold of your arm and scratching it because she's mad at you because you stayed in the bathroom too long or whatever. So those are two examples of what we would call scratches, but they're completely different in their mechanisms and how they would look. Same thing's true for floor covering. So when you drag a couch or a chair or something across the surface of a material, and it's got a little burr on the leg or unprotected foot, and it grabs that floor covering and imparts a visible scratch with depth and what I call a mar or a gouge, you can see that very readily, as opposed to comparing walking into a restaurant and you see where people rotate and turn to pivot, and you've now worn away the surface because of debris on your feet that you've carried in from the outdoors and sort of just abraded slowly with multiple passes. Those are more abrasive actions. So those two things kind of mimic what I was describing with sliding and getting scratched by your sister, just to give you guys some context. So one of the tests that we use is a Tabor abrasion. It's very popular in the laminate world. They use it to provide AC ratings or alpha classifications, and I want to show you a picture of one, and you can see, I'll hold that against the different line. You can see how the surface has been worn, but it doesn't look real horrible. And what we're looking for is tiny areas in 3 of 4 quadrants of this particular circle of abrasion to show actually wear through to the decor layer. The decor layer is underneath the wearing surface, which is some sort of aluminum oxide or a compound of urethane or something that they've applied to that surface, and that's what we're wearing away. And that's a laminate floor covering, which is based with some sort of a MDF based core. And then we have wood also that we run exactly the same test on. You can see that's wood has run all the way through to the color layer and removed the color, and then you can also see the deformation in the visual of where even it's not run through. You still kind of an ugly situation for how that abrasion is visible. And then lastly is a piece of really high-end vinyl that is used in battleships. Actually, this is one. So I'm showing you all these because the same exact test was run on every one of these, and people say, oh, well, we can tell the performance by how many cycles of abrasion, how great it looks, what it does. To get to the same level endpoint to this, where we're going into the color layer, would take about 40,000 cycles. However, this is only 1,000 cycles that you're seeing, and you see how ugly that abrasion looks. Now, Miss Consumer would tell you this is the endpoint, but according to the test procedures, that we follow. It's not the endpoint. It is not based all the way into the color layer. So this sample has 5 times the amount of cycles, 5,000 cycles of the exact same wear structure as this one received. Look how ugly this one is compared to this. However, this is the endpoint. So you get confusing information when you look at just one singular type test when you're talking about scratch, and where the endpoint or the wear through point or the initial point would be. This particular sample on wood probably really looks the worst of all of them. It only has 100 cycles. So again, this test is not necessarily to compare these three things, but I'm just giving you reference as to sometimes a singular test or a singular type of test doesn't always tell you the truth about how a material is going to perform always. It is a piece of information, but it's not a complete fitted puzzle together to solve what material is the best for a particular situation. And I think that's why we would want to use these tests, is to show Miss Smith or Mr. Office Manager, what materials they might want to purchase for their particular usage and the level of traffic and what's going on with it. So I've made some videos again of other mechanisms, how they run, how the test is conducted. I'll run through that and sort of talk over them to describe those a little further. Again, just to provide you guys with information about what tests are available, what you can look for, what you can do, what you can ask for, understanding there is no criterion unless the manufacturer has stated a warranty or some sort of a metric that says, hey, our finish coat will last 5,000 cycles. Well, if they said this about that, then you would have a legitimate claim against them because it only lasted 100 cycles. Whereas an AC rating like we saw on the laminate, if they said, oh, this is an AC rating of 8 and it's actually only a 4, you could certainly have a legitimate claim against them because they made the claim that it would perform that well in that test. So we can't hold their feet to the fire with any kind of industry requirement, except we can hold people's feet to the fire when they make the statement that our test shows X and it passes X. Then we can run that test and find out if it does. So I always tell inspectors or consumers or people looking to try to solve a problem is find what you were told, find what spec sheet you were given, and see if there's any reference to scratching, see if there's any reference to protection. Is it scratch proof? Not a word I like to hear, but some people say it. Everything is only resistance, nothing is proof. So if you see that, make sure and look for that data that's available at some point somewhere when that material was sold, so that we can compare against that and help build the case for or against the material being problematic. This device is the Tabor abrasion. We're using actually 500 grams weight with the S42 sandpaper on a laminate flooring, this particular sample. As you can see, the flooring rotates and produces a kind of a millstone effect to wear the surface away. Here is the Martindale EN 16094 using a weighted surface to scrub or rub the top surface of the material. This is an SPC to wear the surface away or to abrade the surface. Give it a rating for gloss change and for wearability. This straight line tester, ASTM D7027 or ISO 1518, uses a probe stylus to impart a scratch across the surface of the material being tested and to determine the force required to create that mar or gouge being visible to the human eye. Obviously, the higher the force required, the more gouge resistant or scratch resistance the surface would be. Thanks for joining and hope you learned something today about some scratch resistance. If you guys have any questions, let me know.